Hi, everybody. Welcome to Math with Ace, focusing on statistics. We're going to be talking about the five-number summary, the mean, the median, and the mode today. We are dealing with the same data set that we've been using for the box plot video, as well as the percentile and quartiles. This is the number of siblings that an individual has. There are 20 data points here. In the percentiles and quartiles video, we talked about how to find the quartiles as well as the median. Now, the mean and the median and the mode are measures of location of center, and we typically use the mean versus the median, depending on the situation. We use the mean, which is the arithmetic mean, or what most people call the average, when the data has a symmetric distribution and is not skewed. Think about this. You take a test, or you take all of your tests in a semester and you're killing it. You have 100 on every single test that you've taken. And then all of a sudden you happen to be absent one day and you miss a test and you get a 0. What happens to your average? Your 100s drop very low unless you have, 500 hundreds. That 0 really impacts your score. And so the average is not a good representation when you have all of these high scores and then that one value, that one outlier brings things down. The mean should not be used in that situation. The median is a better measure of center in that case, because the middle of your data set is still in that 100 range. So we use the median when you have skewed distributions. The middle of the data set. So when you are looking at a data set, if your distribution is symmetric, the mean and the median are pretty close together, and we'll use the mean in that situation. If your distribution is skewed, the median will be towards the middle, where your mean will be pulled towards your skewness. And so if you are skewed, if that 0 impacts your score, the average is going to be less than what the middle 50% would be. So when we're finding the mode is the number that is most frequent. It's not necessarily the best depictor of the measure of center, but we can say this happens a lot, or this number occurs the most frequently. So if you look at our 20 numbers here, the numbers are in order, which is important when you're calculating the median and the five-number summary. We know that there's 20 data points here, but if you notice, the numbers 0 appear 3 times, the number 1 appears 5 times, the number 2 appears 5 times, the number 3 appears 3 times, the number 4 appears 2 times, 5 appears once, and 6 appears once. So when you're calculating the mode, it is the number that is most frequent. So the number that appears most frequently here are both 1 and 2. So it is possible to have more than one mode. So mode is the number that is most frequently occurs. So in this sense, the mode was 1 and 2. The mean is the middle, and the mean is the average. So when you're calculating the average, you can use a weighted average where you're taking 3 times 0 and 5 times 1 and 5 times 2 and 3 times 3 and 4 times 2, 5 times 1 and 6 times 1, and then divide that by 20. That gives you, instead of having to go 0 plus 0 plus 0 plus 1 plus 1 plus 1, it gives you an opportunity to do a weighted average. Even if I knew that there were numbers that occurred more frequently, I still just add all the numbers up. But let's say you had 1,000 data points and you wanted to use a weighted average, you could, but let's be real, in that situation, you're going to be using technology anyway. I mean, you're going to be using a calculator for this anyway, so it's totally up to you. The median is the middle number, and remember, you can find the location of the median by taking n plus 1 and dividing by 2. It's not the value of the median, but it is the location. The five-number summary is made up of 5 numbers: the minimum, the maximum, the first quartile, the third quartile, and the median, which is the middle. So the 5-number summary going in order: minimum, which is the lowest value, the first quartile, lower quartile is what we'll call it. You have the median, which is also the second quartile. You have the third quartile or the upper quartile. And then you have the maximum. So the 5-number summary is what makes your box plot. It's the smallest value, the highest value, and then split your data into quarters. Quarter 1, quarter 2, quarter 3, and then that gives you 4 separate groups of numbers. The minimum is the smallest number. So in this case, the minimum here is 0. The maximum is 6. Our numbers are in order, which is great. So that tells us the minimum is 0. The maximum is 6. And then again, when we're finding the median and the quartiles, the median is the middle number or the average of the middle two, depending on if you have an even number of data points or an odd number of data points. So n plus 1, 20 plus 1, divided by 2 is 21 over 2, or 10.5. That tells me it's not that the median is 10.5, but it tells me the median is between the 10th and the 11th point or observation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means that the median is right between 2 and 2. And I find the average, and you might be able to go, well, I know what the average of 2 and 2 is. It's 2. That's fine, but it's better to get into the practice of finding the average so that when you have points that are not the same, you do that practice anyway. So the median is 2, as 2 plus 2 divided by 2 is 2. And then that splits your data into the lower half and the upper half. And then I find the median of the lower half and the median of the upper half to find the quartiles. So if there's 10 numbers above and below, since there's 20 points, 10 and 10, and then I would do 10 plus 1 divided by 2, that's 11 over 2, which is 5.5. That means that the lower quartile is between the 5th and the 6th observation. So I go 1, 2, 3, 4, 5. This is the lower quartile. 1, 2, 3, 4, 5. This is going to be the upper quartile. So the average of 1 and 1, the average of 3 and 3, 1 and 3 are our quartiles. I show that in the quartile video. But this is the 5-number summary. And the 5-number summary is what makes your box plot. You have 0, 1, 2, 3, 4, 5, 6. You make marks for each of the values that are in your 5-number summary. Your box goes from quartile 1 to quartile 3. Your median is a line down the middle, and then you connect your whiskers from the quartiles out. Now, your minimum, your quartile, and your median, all of these might not be represented. They might not be different numbers. Let's say you have a data set that's a whole bunch of zeros, and then you have a few other things. So you might get a box that doesn't have a median, or doesn't have a whisker, or doesn't have a box. Maybe it's just a line because the third quartile, the first quartile, and the median are all the same value. That's okay. So just know that the variations of the box doesn't mean you've done something wrong. It just means that the values were the same. And so you would want to do those calculations. So for the average, to calculate the average, what we would want to do is we want to add all of those numbers up and divide by however many numbers there are. So you add all of the observation values and divide by the total number of observations. In fancy mathematical notation, that means this, and we represent it with X bar. So X bar is the sample average. You sum the X's, that's sigma in math, the uppercase Greek letter means add all of the X's and divide by N. That means add X value 1, X value 2, X value 3, all the way up to X value 20, and then you would divide by 20. It's just fancy notation to say, hey, add all these numbers up and then divide by 20. So I'm going to take a second to add these numbers up and give you a sum, and then we're going to divide it by 20. Okay, so when I added all of the values together, I got 43, and then I'm going to divide that by 20. So 43 divided by 20 gives me 2.15. that means that the average is 2.15. So on my box plot, my average is probably right about here. If you notice, this distribution, and you might not have formalized what it means to be skewed yet, but this distribution does not look symmetric. If you folded it in half, the whiskers would not line up. They're not the same length. The right whisker is a little bit longer. That means that the distribution is skewed to the right. That value of 5 and 6, even there's a lot of zeros, a lot of ones, a lot of twos, 5 and 6 pulled it a little bit to the right. So the mean is closer towards the skewness. The median is a more accurate representation of the middle, but the average is pulled to the right. So this is another reason why the median is a better measure of center when you have a skewed distribution. So the 5-number summary, minimum, maximum, and then your quartiles. Quartile 1, median, which is also quartile 2, quartile 3. Make your box plot. You have your mode, which is most frequent, the mean, which is the average, where you add all the data points and divide. One thing I will note for y'all is if you're using a calculator and you go into your calculator and you add 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 5 plus 6. And then you go into your calculator and you say divide by 20, you will not get 2.15. Because your calculator, if you do this all at once, your calculator is going to follow the order of operations and it's going to divide 6 by 20 first and then add all of the rest of these. So it's very important that you either add everything, get that sum, and then divide by 20, or you use parentheses. So either do it in 2 steps or use parentheses around the numbers that you're adding and then divide by 20 because the order of operations is never wrong. Thanks for watching.